So today we're looking at exponent rules for division. If you haven't yet checked out the video about the negative and zero exponents, I recommend doing that before starting this lesson. Now, some general info to just recap. We looked at this at the beginning of the multiplication rule video, but remember that exponents are a way to represent repeated multiplication. So if you see repeated multiplication of the same thing, you can rewrite that using an exponent. Or if you see a term and you want to break that apart, you can. So the exponent tells you how many times that thing is being multiplied by itself. We're going to use this strategy to help us reduce things with exponents here in the next section, kind of like we did with the multiplication rule, but this way we'll be doing division. So we'll see the same kind of things. All right, so the rule for division is that your coefficients are still going to divide or reduce. Just like they normally would. Now what you don't want in this section is decimals. So if you divide and get a decimal, please turn that back into a fraction. For exponents, they're going to subtract. If you can remember the multiplication rule where it said that the coefficients multiply and the exponents add, division is the opposite of multiplication. So the exponents also do the opposite. Instead of adding, we're going to end up subtracting them. Some of the things still cross over, so you can only combine exponents if they have the same base. You can also still divide or reduce coefficients even if the terms have different variables. Exponents of 1 will still show up in this section, kind of like they did for multiplication, but the weirder thing that's going to show up are negative exponents. So if we start taking a look at this rule in action, if I have x to the 12th divided by x to the 4th. We have just a coefficient of 1, so the coefficient piece isn't going to come into play on this problem. We're just going to subtract our exponents. So if I think of what 12 minus 4 is, that's going to give me 8. So my final answer is going to be x to the 8th power. If we take a look at the next one, this one does have the coefficient piece to it. So I'm going to take those two big numbers and we're going to actually divide those. 10 divided by 5 is going to make 2. And 7 minus 3 will make 4 on my exponent. So 2x to the 4th is my final answer. Now, if it seems a little strange and you're not sure where these are coming from, here's how this works. What happens is we have 10 and then on the top we have 7 x's, using the idea that exponents represent repeated multiplication. On the bottom, I have a 5 and 3 x's. Now in any fraction, if you have the same thing on the top and the bottom, those things cancel out to 1. They reduce with each other. So if I see something like x divided by x, that's really just 1. X divided by x, 1. And it allows me to cancel out some of my x's. So I still need this 10 divided by 5 part here. That is still going to give me 2. But take a look at what we have left after canceling out those x's. We have 1, 2, 3, 4 x's left, and that gives me x to the 4th as part of my answer. So you can use that strategy without really using the rule in case it's a little confusing or you feel a little more uncomfortable with this. People tend to struggle with this rule more because they are less comfortable with fractions. Speaking of fractions, in this next example, we have two coefficients that don't really divide with each other. Instead, these ones just reduce. You can use a calculator to help you do that if you're not great at reducing on your own. So what you can have is something like 12 divided by 15. It does turn into a decimal, but we already established, please don't have any decimals. So on a TI-84 plus, in my case, color edition, if you go math, enter, enter, it should reduce that fraction for you. So our fraction here is going to end up being 4 over 5. This example also brings in those exponents of 1, so just remember that that exponent is there. So 4 minus 1 makes x to the 3rd. In our next example, you'll notice that the bigger exponent is actually on the bottom. And what that's going to cause for us is a negative exponent. So take a look. If I subtract, this coefficient of 2 isn't going to change, but if I subtract and do 2 minus 11, I get negative 9. Now, if you think back to our work with negative exponents earlier in a different video, then what happens with that negative is that it moves so that it's, again, happy. So it's going to move down to the bottom. We're going to create a fraction, and it's going to look kind of like this, 2 divided by x to the 9th. Now, if that seems a little bit weird, we can, again, use that idea of repeated multiplication. So 2x squared will look like 2 with 2 x's. And on the bottom, we have 11 x's going on. All right, I can again cancel a couple of these x's out. It doesn't really matter which ones you choose. They're all the same. And so now look at the difference. So in this example, we had the 4 x's and they were left up here on top with that 2 or 2 over 1. Here, the 2 is on top, but all of my x's are still on the bottom. So I can't magically bring those up to the top. I do have to leave them down on the bottom. So sometimes it's easier for me to still say 11 minus 2, but then think, okay, 11 was the bigger exponent, so my exponent piece there is going to have to end up on the bottom. Okay, similar deal over here. If I do this and do 3 minus 9, I get x to the negative 6th power. But negative exponents aren't okay in your final answer. I do have to flip this down to the bottom. But I also don't see anything in the top. So we have that placeholder of a 1 there in the front, making 1 over x to the 6th our final answer in that one. Again, you could take the time to write that all out with 3 x's on the top, 9 x's on the bottom. The 3 x's on the top would cancel out and leave you with 6 x's on the bottom. One other weird thing that can happen is if your exponents actually match. So if I have y to the 5th over y to the 5th, and I think about that like subtraction, 5 minus 5 is going to make 0. Again, referencing that negative and 0 exponents lesson that we did previously, anything raised to the 0 power equals 1. So our final answer is actually 1. You can think about that breaking it all apart. I'd have 5y's on top, 5y's on the bottom. And technically there are coefficients of 1 out here as well. So when I cancel things out, I have a y with a y, and I actually have that same thing happening 5 times. 1 from the top, 1 from the bottom, canceling with each other. So all of my y's cancel out, and I just have 1 divided by 1, which again is going to equal 1. All right, we start throwing in multiple variables here on the next example. So this make sure that we touch on the fact that I can only combine a's with a's. I can't combine a's with b's. So if I have a to the 7th over a squared, I can turn that into a to the 5th, getting that from 7 minus 2. The b squared didn't have any b's on the bottom to cancel with or to do anything with, so he just stays in the problem. If you see this broken out, you have 7 a's and 2 b's on top, and then 2 a's on the bottom. Okay, and you can cancel any 2 a's you like from the top with those 2 on the bottom, and that should leave you with these 5 a's and 2 b's up there on the top. Okay, our next example shows that you can still divide or reduce your coefficients even if the terms have different variables. It just means that I can't subtract these two numbers. I'm not allowed to combine the 5 with the 2 because they have different bases. But I am still allowed to do 18 divided by 3 to give me 6. And the y squared will have to stay down there on the bottom. All right, just 2 more examples. This one, all my bigger exponents are up on the top, so I shouldn't have to deal with that negative exponent piece on this one. 24 divided by 6 makes 4. 5 minus 1 will make x to the 4th power. And I'm also going to combine my y's with my y's. 9 minus 2 will make 7. All right, the last one is a little bit weirder. We have another fraction here. 6 over 12 are reduced to 1/2. 8 minus 5 will make 3. 2 minus 9 will make negative 7. And I have a lone z that will just stay in my problem. So I am going to rearrange this a little bit and kind of adjust. I have a negative exponent that needs to move to a different section of my problem. The 1/2 is going to create the fraction for me. So x to the 3rd was happy right where it is, using those negative kind of ideas that we had with positive exponents being happy, negative exponents being unhappy, and needing to move to become happy again. And then we have that z that's already happy, and it's going to stay up there on the top. You could also rewrite this without the 1 in your 1/2 now that we have other things up there in the numerator to take its place. So x to the 3rd z over 2y to the 7th is the best answer. This one is great as well. This one is not quite ready to go because of that negative exponent. Now, if you're ready, this is a great time to pause the video and try those last 3 problems on your own. So now that you've tried those, these are the answers that you should get. You should have 7x to the 9th, 14 divided by 2 makes 7, and 12 minus 3 makes 9. In the next one, we have a fraction that just reduces, and you're going to end up with a negative exponent that will need to move. So your final answer should look like 4 over 7y to the 10th. And last but not least, you'll have some negative exponents going on. You'll have a positive exponent, a fraction that just reduces, and you have a lone z squared that's just going to come down into your problem. Your final answer should look like 5x squared z squared over 4y to the 4th.